one day erupt again. Here, there are a grouping of pristine lava flows which may be associated with reports from indigenous peoples that one of these volcanoes may have erupted 3 times during the last 2,300 years. If you zoom out, the areas with recent volcanism are easy to spot, forming solid landforms of a light brown color which do not have the abundant thermokarst lakes that surround them. However, from a scientific perspective, we have absolutely no clue how old most of these volcanoes as a whole truly are, or even why their geologic setting allowed them to form in the first place. Ingakslugwat Hills. It is for this reason that I wish to highlight a potentially active volcano which essentially has zero information on it other than a brief mention that it does indeed exist. And, now I wish to present my interpretations about the Ingakslugwat Hills volcano. The Ingakslugwat Hills volcano is located in far western Alaska where it is 35 miles northeast of the nearest populated place known as Nutok. This volcanic field consists of small shield volcanoes and their associated collapse pits in addition to more than 30 cinder and spatter cones and a cluster of volcanic explosion craters known as maars. These maars indicate an explosive potential for this remote volcano, meaning it could disrupt some regional air traffic if it was to ever erupt again. The vast majority of its vents are located along 24-mile-long and 18-mile-wide base of highly fluid lava flows which reach a maximum of 330 feet thick in this overall 1,500 square kilometer volcanic complex. Based on the level of erosion present, I would estimate that the 40 total vents range in age from 5.8 million to 20,000 years old. These vents largely occur along trends of activity which vary throughout the volcanic field. This suggests that while yes, slow extensional forces are a factor in the volcanism at the Ingakslugwat Hills, that another more important factor is involved. For that, I want to bring your attention to a several million-year-old vent which has what appear to be a strike-slip fault running right through it. This fault is likely part of a 260-mile-long unnamed larger fault which accommodates some of the region's uneven motion. This is why Bering Sea basalt province lava appears to erupt either along this fault trend or near perfectly perpendicular to it. While the exact nature of why this volcanism is occurring is unclear, we do know that evidence points towards partial melting of underlying oceanic crust being involved. Along with the volcanic field adjacent to the town of St. Michael, the Ingakslugwat Hills and 8 other active, dormant, and extinct volcanoes comprise what is known as the Bering Sea basalt province. This province's volcanoes mostly erupt in the same moderately explosive manner and started erupting around 6 million years ago. Let's now focus on the tallest point in the youngest vent, Ingakslugwat Hills, as it also happens to represent its most pristine vent. This cinder cone is 71 meters or 233 feet tall and 438 meters or 1,436 feet long. It seemingly erupted at the same time as 7 small spatter cones a mile to the northeast, which themselves were only likely active during the early stages of the relevant eruption. Once these spatter cones ceased their ancient effusive eruption, all lava from the underlying dike was transferred to the cinder cone, which subsequently erupted via intermittent ash ejections and continuous lava fountains. Across what I estimate to be a 44-day-long eruption, this cinder cone erupted at a high rate, rapidly covering 40.54 square kilometers and 283.8 million cubic meters of basaltic lava. This eruption likely had a VEI of between a 1 and a 2, and probably would be the expected size of an eruption if the Ingakslugwat Hills were to erupt again. A final note: if any of you wish to study this volcano, I want you to know this crucial detail. Volcanoes in the Bering Sea basalt province seem to erupt basalt throughout its entire lifespan except during its beginning and end stages when instead feuillite and basanite infrequently erupt.